Take a look at this generated video of a concrete block crumbling. Concrete is incredibly heavy and handles compression well, but on its own, it struggles against stretching or bending stresses, making it highly prone to cracking without internal help. To solve this, builders use reinforcement matting. This is a grid of interconnected steel bars placed inside the concrete that acts as an internal skeleton, giving the material the tensile strength required to carry heavy loads. By the end of this tutorial, you will know exactly how to measure, bend, and construct a perfectly tied, rigid steel grid that is completely ready for a wet concrete pour. Mastering this skill means the difference between erecting a structure that stands secure for decades versus building one that eventually collapses under its own weight. Before touching any raw materials, you must put on thick work gloves and steel-toed boots. The cut edges of steel bars are razor sharp and will cause serious injuries if handled improperly. Next, assemble your required gear. You need a standard measuring tape, designated steel cutting tools, a specialized bending jig, and plenty of steel binding wire. You will be working with two primary steel components, the long, thick structural reinforcement bars and the smaller, separate steel loops known as links. Staging the correct tools and wearing the right safety gear allows you to handle heavy material safely, maintaining the swift, precise workflow required for professional steel fixing. Looking at this technical reference under the size and number of steel bars section, the first step is measuring and cutting the main bars. The sizing rule is direct. Larger buildings require thicker steel bars to support the increased weight. Section 7 defines a jig as a device to manually bend raw steel into exact angles. Moving up to Section 6, the jig is used to bend the far ends of main bars into tight, curved shapes, known as hook ends. These hook ends serve as physical anchors. When wet concrete eventually hardens around the curved shape, it locks the smooth steel in place and prevents it from slipping out under tension. You also use the jig to quickly manufacture your links. The mechanism ensures that every single small loop you produce is bent to the exact same size and shape. Taking the time to create uniform, precise angles with the jig ensures that all these separate steel components will tightly interlock during the layout phase. Step 3 is arranging the steel. The physical layout pattern is dictated entirely by the shape of the structural element that the foundation is going to support. Shown here in Section 1, strip foundation matting is designed for long, continuous loads, like a house wall. For this, the steel bars are laid out horizontally in long strips to distribute the weight evenly along the trench. Conversely, Section 2 displays pad foundation matting. In this layout, bars are arranged tightly into a square or rectangular shape, which is required to support a single heavy point load, like an upright concrete pillar. This animated diagram demonstrates the assembly action. You first lay out the main horizontal bars into your correct pattern, and then slide the smaller rectangular steel links over the top of them to construct a cohesive grid. When placing links, they must be distributed evenly at strict intervals. This split-screen diagram highlights the risks. Left, spacing links too far apart creates a weak zone that buckles. Right, placing them too close wastes material with no added benefit. Executing the correct geometric arrangement and exact spacing ensures the final foundation will spread massive weight loads safely into the surrounding soil. With the grid laid out, you must secure it. Using standard binding wire, you have to individually lock down every single intersection where a rectangular link crosses over a main structural bar. Watch this close-up video. Wrap binding wire around the joint, twisting it repeatedly with a metal tool until it aggressively cinches the two bars together. Leaving these wire ties loose is the most common and dangerous mistake made during the assembly phase. To test your work, grab the tied joint and vigorously shake it. If you feel any wiggle at all, clip the wire and retie it tighter. Once the grid is fully secured, lift the completely rigid matting as a single unified block and carefully lower it into the wooden formwork trenches. Only a perfectly tied grid can survive the heavy, chaotic impact of wet concrete pouring down over it without shifting and ruining the structural layout. With the matting resting inside the formwork, walk around the trench to perform a final visual inspection. Verify your work against this standards checklist. Ensure your main bars are evenly spaced, your links are properly shaped without warping, the wire tying is visibly tight, and the final layout matches your required measurements. To remember this sequence for future jobs, lock this acronym into memory: SPSLHJ. That breaks down to strip foundation, pad foundation, size of the bars, proper links, curved hook ends, and using the jig tool. By accurately cutting, bending, and tying this internal steel skeleton, you ensure that the final concrete structure is highly resilient, entirely safe, and ready to carry heavy structural loads.